was because I'm assuming that you guys know what the graph of life is at school. So there's a smiley face parabola. Yes. And what we're going to use is something called the rectangular approximation method. Which we call RAM. Rectangular approximation method. The first thing I'm going to do is make sort of a random guess on how many divisions I want to make of rectangles. If you think back to that reading we were doing where we had a picture of the jet, the smaller we made the rectangles, the closer we got to the right angles, but then you had to add up more of those. So looking at this, I think that if I split this up into fours, that I could start to get a pretty good idea of what the area ought to be. I would like to be systematic. In fact, what I kind of like to do is be able to set it up on a spreadsheet, but I don't think the calculators can use spreadsheets. But we can still set our calculators up to do most of these type of things for us. When I start to imagine these rectangles, I'm going to do it two different ways. I'm going to start on the left, and I'm going to then go around, and I'll start on the right. One will be too big, one will be too small. How will I get the right answer? Average. Probably add them together. When you look at the book, they're going to tell you how many divisions they want you to use. If you were going to go out and do this for real in a real life situation, it's kind of up to you on how many divisions. When they figure out how much water is in Wolford, somebody had to go through and they had to make rectangles across the lake. So if you imagine them envisioning a set of rectangles, you could get more and more rectangles if you wanted to spend more money for the surveyor. I think they measured them out in 10 foot, you get this 20-foot grids. You can see if you wanted to do more precision, you could go for a 1 foot, but then it costs you 3 times as much. So it just depends on how much you want to hire the surveyor to do. And apparently 10-foot grids were enough to get a pretty good approximation. So we're going to go that squiggle on top is supposed to be a 3. If I start at the left, and make my rectangles. The first rectangle would start from here. It would come up to touch the curve, and it would come out to have a height of 0. The next curve would come up to here, and you can see that it would have a height. Well, how would I figure out the height? I like it. There's the answer. Go ahead one more time, Shay. So the calculator would say (1/2) squared. Why did I put the 1/2 in and square it? So will you be able to see 1/4 for an answer? This is a y, this is a 2, that's a 2. Because the graph is a y equals x squared.
So the height is a quarter?
So the height on this rectangle is 1/4. Now notice what's happening here is we're trying to make something that's going to look like a nice orderly progression. We're going to take the width, which was 1/2. We're going to multiply by the height. On that next one, the width was 1/2. So from here to here was the 1/2. We're going to multiply by the height. I'm figuring out that height because I know that the function gives me the height. So when I get to this next rectangle, I can figure out the height because now I happen to be at the number 1. It will help you if you start to see patterns. So would you notice that my pattern is this was a 0, this was a 1, this was a 2. This next rectangle would be right here. That would extend out to the 2. I do not go out to the number 2 because that would start a rectangle that's outside of my areas. Looking at that area, is the area going to be too small or too large? So this is the inscribed area. And LRAM is not always going to be inscribed. Matter of fact, if you looked at the example we had at the front of the chapter, that would have been a circumscribed. We repeat this, but we do it with starting at the right. If you started at the right side, you would be starting here. If you're starting here, the width of the rectangle is going to be a 1/2. If I wanted to figure out the height, I'm starting at the number 2, which I'm going to express. Folks, what's 2 if you had it in 4? Would you be able to say it's 4/2? Now, folks, the tricky part you're going to have is how do you end up getting this into, how do you know where to stop? So can you see that when I've done this, I should always end up with the same number of divisions as what they said. They decided to pick n as 4. So can you see I've got 1, 2, 3, 4 things? Would you notice that when you start on one of them, you generally start at a small number, you're going all the way up and generally stopping one short of the last? So let's go ahead and put this into a calculator. So does everybody have their 89s? If you would get those out for me.